Hello and welcome to this video that goes through the physics and maths tutor questions for the chain rule for year 2 differentiation. So the first question, question 1 is find the value of dy dx at a point where x equals 2 on the curve with the equation y equals x squared times the square root of 5x minus 1. So this one you've got two functions of x, so we can say this is f of x and this is g of x, or actually better to take it as u and v. And when you've got two functions that are multiplying each other, you're going to use the product rule. Now the product rule you are not given on the formula sheet. You have to remember this. So when you have y equals u times v, or f of x times g of x, dy dx is equal to du dx times v plus dv dx times u. It doesn't matter the order. You might see this as u prime v plus v prime u. So when we've got this set up here, we are going to define that u is equal to x squared, and we're going to differentiate it. So du dx is equal to times by the old power, so it's 2x, and reduce the power by 1, so that becomes 2x. And then the second one is v is equal to root 5x minus 1. Now this one we're going to solve by using the chain rule. So we can rewrite v as 5x minus 1 to the power of a half. And then we go ahead and use the chain rule. So I'm going to say a is equal to 5x minus 1. So the chain rule is essentially used when we've got a function within a function. So here we've got 5x minus 1 inside a square root. So it's a perfect opportunity to use the chain rule. So take out substitution, a equals 5x minus 1, and dA dx is equal to 5. And here we've got v is now equal to a to the power of a half, because we replaced 5x minus 1 with a. And then when we differentiate, we get dv dA. And then we're going to times by the old power, so half a, and then reduce the power by 1, so it's minus a half. When we put this together, so our goal is to get dv dx. This is equal to dA dx times dv dA. And here we get back our dv dx, because this one and this one will cancel. So therefore this is equal to 5 times a half a to the power minus a half. And then from here, all we do is we then say, well, this is 5 over 2, 5x minus 1 to the power of minus a half. And that gives us dv dx. So now we've got dv dx, what we can do is we can then substitute that into our product rule equation. So this is equal to, so dv dx is equal to 5 over 2, 5x minus 1 to the power of minus a half. Plugging this into our product rule, dy dx is equal to u v prime. So that's going to be x squared 5 over 2 times 5x minus 1 to the power of minus a half, plus v u prime, so that's going to be 2x root 5x minus 1. From here, it's just asking you to find the value of dy dx when you plug in the point x equals 2. So here you can, if you want to, simplify, but there's no need to, because you can just say, well, if x equals 2, dy dx is equal to 2 squared times 5 over 2 times 5 times 2 minus 1 to the power of minus a half, plus 2 times 2 root 5 2 minus 1. And then you're just going to plug that into the calculator. Probably best to plug it in directly. So 2 squared times 5 over 2 times bracket 5 times 2 is 10, minus 1 to the power of minus a half, plus 2 times 2, which is 4, root 10, 5 times 2, which is 10, minus 1. Plugging that in will give you an answer of dy dx is equal to 46 over 3, and that's your final answer for part A. For part B, we've got differentiate sine 2x with respect to x. So when we want to differentiate sine 2x, this one we're going to use the quotient rule. So the quotient rule is given to you in the formula sheet. If we go down to the formula sheet, we see that it's under the differentiation section, and we can see that when you have a function f over x divided by g of x, then we've got f prime x gx minus fx g prime x divided by g of x squared. So another way we can say this is when y is equal to u over v, then dy dx is equal to u prime v minus v prime u divided by v squared, where u prime is du dx and v prime is dv dx. From here we're going to plug it in, so our first one we've got is u is equal to sine 2x and v is equal to x squared. So for sine 2x you need to memorize how to differentiate. One way that you could do this is to memorize a circle, sine cos minus cos, and going clockwise around the circle means that you differentiate. Another rule that you need to remember is that when you differentiate a trig function, so for example sine 8x, if you differentiate this, so dy dx, then it's a cos a of x. So anything that's multiplying the x needs to come out. So here when we've got sine 2x, this becomes du dx is equal to 2 cos 2x. When we've got x squared here, this is dv dx, which is equal to 2x. From here we can plug this into our equation, so dy dx is equal to u prime, so this is going to be 2 cos 2x times v, which is x squared, minus v prime, so that's going to be 2x times sine 2x, divided by v squared, which is x squared squared. Plugging this in, we get a result of 2x squared cos 2x minus 2x sine 2x divided through by x to the power of 4. Now here it doesn't say to simplify, so you could leave your answer like this, but one thing that we could do is you could take out a factor of x and at the top, so we could take out a factor of x, we get x 2x cos 2x minus 2 sine 2x divided by x to the power of 4, and then the x here and one of the powers cancel, so we end up with x cubed instead. So we end up with 2x cos 2x minus 2 sine 2x over x cubed. And again, you could also take out a factor of 2 here. So it's 2 bracket x cos 2x minus sine 2x over x cubed, but that's not necessary. And that gives you your final answer for question number 1. Usually if you want it in a simplest form, there is a way, or there'll probably be a clear way of solving it, or it might ask you to solve it in a particular way, like show that question. Otherwise, if it doesn't ask you to do that, then usually you can leave it in the form without simplifying it too much. Question 2. Find the equation of the tangent of the curve x equals cos 2y plus pi at 0 pi over 4, giving you answer in the form y equals ax plus b. So here we're going to solve our equation. So again, we've got x equals cos 2y plus pi. Now this one, be careful that you do the correct way of solving this one, because we've got x as the letter and everything else is in terms of y is in terms of x is in terms of y. So when we differentiate, it's dx dy that we've got here. Now we've got cos here, so we've got sine, cos, minus cos. So cosine is going to differentiate into minus sine. Now here, there's the plus pi bit, which can be confusing when we're differentiating it, but we don't need to worry about this. What we can do is we can just bring the 2 outside. So the general rule, again, is anything that's multiplying the term inside the cosine or the sine, we bring it out. So here it's just a 2. So dx dy becomes minus 2 sine 2y plus pi. And then because we want it in the form y equals ax plus b, in reality we want to find what dy dx is. We're going to say that dy dx is equal to 1 over dx dy, which is equal to 1 over minus 2 sine 2y plus pi. Again, the reason why we've done this is because we want to find the gradient. We're looking for the tangent to the curve, so therefore we need to find the gradient. To find the gradient from here, we've got dy dx equals 1 over dx dy. So we can just substitute in the values. So in here we've got x equals 0 and y equals pi over 4. So dy dx is equal to 1 over minus 2 sine 2 pi over 4 plus pi. Substituting this into your equation, it's going to be minus 1, or 1 over minus 2 sine 2 pi over 4 plus pi. It's very important that your calculator is in radians because you are dealing with pi. Plugging that into your calculator gives you a gradient of a half. As it's a tangent, so the tangent means that the gradient of the curve is equal to the gradient of the straight line. And from here we can use our formula, so either y minus y1 equals mx minus x1, or just using y equals mx plus c. We know that x is 0 and y is pi over 4, so y minus pi over 4 is equal to a half bracket x minus 0, and that leaves us just by rearranging the equation, so y is equal to a half x plus pi over 4. And that's your final answer. You can say a is equal to a half, b is equal to pi over 4, but you can just leave your answer in that form as well. Question 3, differentiate with respect to x, e to the power 3x plus ln 2x. So the general rule for e to the x, you can either memorize this one or use the chain rule. So if you've got if y is equal to e to the f of x, then dy dx is equal to f prime x, so the differential of the function, e to the f of x. So here, or alternatively, you could use a chain rule. So here, if we just treat y equals e to the 3x, then dy dx using this one, f of x is equal to 3x, so f prime x is equal to 3. So it's just equal to 3e to the 3x. Or you could use a chain rule. So the chain rule, you would say that it's u equals 3x if y is equal to e to the 3x, and y is equal to e to the u. Du dx is equal to 3, dy du is equal to e to the u, because that's the fact about e to the x. If you differentiate it, it's also e to the x. And then dy dx is equal to du dx times dy du, which is equal to 3e to the u, which is equal to 3e to the 3x. The next one we have is ln 2x. So this one, if we treat this one, this is y equals ln 2x. So here we're going to use a chain rule, so u is equal to 2x, and y is now equal to ln u. du dx is equal to 2, and dy du is equal to 1 over u, which is a rule that you need to remember. So if you ever have y equals ln something, so ln x, dy dx is equal to 1 over x. This is a rule you need to remember. Again, here we're just replacing the x with a u. Then we say that dy dx is equal to du dx times dy du, and that's equal to 2 over 2x, which is equal to 1 over x. Therefore, when we differentiate these, we're going to put these two results together. So dy dx is equal to 3e to the 3x, for e to the 3x, plus 1 over x. The next one we've got, part B, is 5 plus x squared to the power of 3 over 2. This one is a straight chain rule. A is equal to, so we're going to rewrite this one, so we're going to say y is equal to 5 plus x squared, 3 over 2. We're going to say that a is equal to 5 plus x squared, and we're going to differentiate this, so dA dx, 5 differentiates to 0, and x squared differentiates to 2x. And then we've got our y term, so y is equal to a the power of 3 over 2. So dy dA, again, multiply by the power, it's 3 over 2, a, and then reduce the power by 1. So 3 over 2 minus 1 is equal to a half. Again, these ones are very simple sums, but very easy to make mistakes on, so don't be afraid to use a calculator just to check. And then for here, so that's a to the power of a half. So then we say dy dx is equal to dA dx times, and this is a mistake, so it should be dy dA, apologies, dy dA, that's equal to 2x times 3 over 2a to the power of a half. 2 times 3 over 2 is just 3, so it's 3x times a, so it's 5 plus x squared to the power of half. And that's your final answer for part B. Next question, question 4. A heated metal ball is dropped into a liquid. As the ball cools, its temperature T minutes after it enters water is given by T equals 400 e to the power of minus 0.05 T plus 25. Find the temperature of the ball as it enters the liquid. So when it enters the liquid, this is when T is equal to 0. So the temperature of the ball, big T, is 400 minus 0.05 times 0 over e, so e to the power of minus 0.05 times 0 plus 25. Plugging this in, it's e to the power of 400 e to the power of 0 plus 25, so t is equal to 425. Find the value of t for which t equals find essentially the time for when t is equal to 300, giving your answer to 3 significant figures. So for part B, we know that t is equal to 300, so it's going to be 300 is equal to 400 e to the power minus 0.05 t plus 25. So here we're going to rearrange our equation to find little t. So first things first, we subtract both sides by 25 to get 275 is equal to 400 e to the minus 0.05 t. Then we're going to divide by 400, so 275 over 400 is equal to e minus 0.05 t. 275 over 400 gives 11 over 16, which is just a bit easier to write into the calculator. And we're going to take the opposite. So when you want to move base e to the other side, you have to take log base e, which is the same as ln. So you're going to take ln on both sides. So it's going to be ln 11 over 16, which is 275 over 400 simplified, equals, now ln e cancels, so we're left with 0.05 t. From here, we're just going to divide, so ln 11 over 16 divided by minus 0.5 is equal to little t. So little t is equal to t is equal to 7.49. And check what the answer is looking for. So it's looking for 3 significant figures, so we can leave our result as it is, 7.49. Question part C. Find the rate at which the temperature of the ball is decreasing at the instant when t equals 50, giving the answer in degrees per minute to 3 significant figures. So here we want to find the rate, so the rate is going to be d little t. So if we start with 400 e to the minus 0.05 t plus 25, this will go to 0. So this part here, I'm going to, so we can use the rule actually here, or you can use the chain rule. If we use the chain rule this time, so we're going to say that, so if t is equal to 400, we just split this up, t, then we can say that a is equal to 0.05 t, and dA dt is equal to minus 0.05, and then t is equal to 400 e to the a, and if we differentiate this, dt dA is equal to 400 e to the a. So plugging this into, so finding dt is equal to dA dt times dt dA, that's equal to minus 0.05 times 400 e to the a. Plugging this in, 400 times minus 0.05 is equal to minus 20. So so the change in temperature, change of time, so d big T divided by d little t is equal to minus 20 e, and a is minus 0.05 t. Plugging in the answer that we want, so we want it when little t is 50. So when t is equal to 50, dt is equal to minus 20 e to the minus 0.05 times 50. Plugging this in is equal to minus 20 times e to the 0.05 times 50, it is equal to minus 1.64. And again, we're just double checking, we want it to 3 significant figures. So that is our answer, so it's minus 1.64 degrees, and it's going to be degrees per minute as the time. Little t is in minutes and big T is in degrees. From the equation for temperature T in terms of T given above, explain why the temperature of the ball can never fall to 20 degrees. So why can't it fall to 20 degrees? So essentially here we're going to look at a big T. So let's say that T is equal to 9,999. So big T is 400 e to the minus 0.05 times 9999 plus 25. So plugging that in, we can see that, so the reason why I'm picking a big number is because it's saying it can never reach that, so that implies that the time is very, very large. So just pick a very large T, and plugging it in, we get big T is equal to 25. So therefore, we can state that as t goes to infinity, so as t gets really, really large, t will tend to 25. And that's your answer. If you wanted to, you can be more exact. You can say that e to the power of minus 0.05 t will go to 0 as t goes to infinity, because if you draw the exponential graph for this one, with t on here, you have a graph that looks like that, which is e to the minus t, or in this case you've got minus 0.05 t, which will have just a stronger gradient. But yeah, essentially you can prove that by just plugging in some numbers and then saying, well, as t goes to infinity, big T tends to go to 25, which is greater than 20.